On a Wednesday morning in late winter, technicians at NASA's Langley Research Center hovered around a small helicopter sitting under a 240-foot tall structure known as the Landing and Impact Research Facility. Inside the lightweight MD-500 chopper were 4 crash test dummies, 3 of them standard head-to-toe models, 1 a special torso equipped with simulated internal organs. Also on board, instruments that can record 160 channels of data that researchers will turn into information that may make helicopters safer.
We have accelerometers that measure the acceleration. We have video cameras that will measure the actual conditions at impact, the velocities, the attitude at impact. We also have load cells on the crash test dummies.
To do their research, engineers used cables to suspend the helicopter 35 feet in the air. Then they dropped it to simulate what they say is a relatively severe but survivable crash.
3, 2, 1, release.
The helicopter skidded to a stop after falling at a rate at about 33 miles an hour. Its body and occupants looking a lot worse for wear after an impact as high as 40 Gs.
We see that the skid gear swayed out and deformed. Both seats, the passenger seats and the crew seats, failed. We see some buckling. Of course, we won't be able to fully assess the damage until we take the helicopter back into the shop.
What researchers at the Hampton, Virginia facility already knew was that this helicopter was a lot more damaged than it was after a similar crash test last year. That's when engineers were testing a special honeycomb cushion called a deployable energy absorber. It was attached to the underside of the MD-500. If developed further, researchers say similar technology might someday help prevent injuries.
Release.
The helicopter was dropped from the same height with the same dummies and instruments inside as the second test. But the accordion-like cushion did its job, and the helicopter and its occupants survived intact enough to be crashed another day for the final time.